What's up, Alice? Your dad's first attempt to make a YouTube video about math. So, I want to talk to you today about a upper division engineering course. I teach Aerospace Engineering 112 at San Jose State, Static and Mechanical Materials, and I want to talk to you about the first topic that you need to know, understand, and master before moving on. Okay? That essential topic 1 is going to be the equilibrium of particles in 2D and 3D. I'm going to go through the example 1 today, edit it, upload it, and then hopefully early next week I'll have a second example of the equilibrium of particles in 3D. So let's get to our first example. The question we want to know is, what problems do I need to know how to solve? Like, what do I need to get out of the book? What do I need to read? Stuff like that. So the things that you need to absolutely know before moving on are how to resolve vectors into I, J, K, X, Y, Z, or any other three-dimensional right-handed coordinate system, PQR. It doesn't matter what letters you use as long as they're compliant with the right-hand rule and they're all orthogonal to each other. Okay, second skill I need to know that I need to teach you is how to identify the directional unit vector lambda. I put subscript AC. Generally, there's two letters, one from where it begins and the other where it's pointing. So in this situation, there would be it starts at the point A and then goes to C, so we call it lambda AC, and again, that is the directional unit vector. Okay, so let's get into the first problem we need to solve today, and I'm really big on RTQ and ATQ. Read the question, answer the question. Later on, we can get bogged down in being able to solve all these intricate things that we don't need to solve. Right now, we just want to read the question, answer the question, move on. Okay, save our time for other problems. So, first of all, we need to resolve vectors into X and Y components. Okay, so problem statement says resolve P and Q into X and Y components. All right, so I have my camera set up here, and we need to go ahead and redraw this. And for this series, I'm going to make sure that I use colors consistently. If you're colorblind, I'm sorry, I can't help you. But for the rest of us, know that I'm going to stick to a certain set of criteria for when I use blue, red, green, purple. Sometimes I'll use orange. Yellow is a difficult one for me to do because yellow on white is really hard to see. So I'll draw your attention to things, and if you know it's there, you know it's there, and if you don't know it's there, then it doesn't bog the picture down. Okay, so blue I'm going to use for coordinate axes, and notice that when I draw, one side does not have an arrow, the other side does have an arrow. This is a vector, and so this is a vector of 1x long. So I'm actually going to give it a hat because it is 1 unit in the X direction. This guy starts negative and goes positive to the Y hat direction. Okay. Then I'm going to use red for vectors. So Q goes off somewhere like this. Okay. Yep. And then P goes off somewhere like this. And I know that I drew this straight. That's not the way the problem is, but it is what it is. Okay, green for angles or measurements. So it looks like we have alpha here, beta there. Okay, question becomes how to resolve P and Q into X and Y components. Okay, so what I'm going to do here is start with a number. So step 1, I'm going to say resolve P and Q. Notice that I put harpoons on top of here because this lets us know that P and Q are vectors. Yeah, I didn't put harpoons here because the harpoon is literally drawn in red. So here is the harpoon, here is the designated letter, here is a designated letter. That's what lets me know that it's a vector. Okay, so how to resolve P? So P is going to be comprised of both an X and Y components. So let's deal with X first. I'd like to start there. So in the X direction from the origin to P, it is going to be going in the negative X direction. So I'm going to start off with a negative P. And the vector symbol drops off here. And so this is only the magnitude, how big it is. I don't know how big it is. I don't care how big it is. All I need to know is how much, here's my time to use orange. How much P is in the X hat direction. Okay, this is like the dot product. The projection of P onto X is this amount here. And this amount here is the magnitude of P times the cosine of alpha. Okay, that takes care of the first component. So draw a little X hat there. That is one component of vector P in the X hat direction. Okay, I move on to the Y hat component. And again, I want to know how much of vector P is projected onto Y. I could go through the shenanigans of finding what this angle is here, but I'm not going to. I'm going to use the same alpha that's given, except I'm going to use the sine of it. Okay, so we will do plus P sine of alpha in the Y hat direction. Boom, we've now done it. We have resolved P into its components in the X and Y directions. Now we can move on to vector Q. Same song, different dance here. Normally, students like when the angle is given off of the x-axis, then they can revert back to some trig things and say that cosine is always in the x and sine is always in the y. Not always going to be the case with us. Whatever angle is easier to find, however we draw it, we need to be able to be flexible enough to know that if angle beta is off of the y-axis, then we just need to use some trig to our advantage and stick and move there as well. So in the x hat direction, we're going to be going positive. Because remember, this is the projection of Q onto the x-axis, which is this direction, positive. Q. Now, this distance here on the x-axis and this distance here are the same. This vector and this vector, same. Okay, so going back to trig, if we want to use beta, we're going to say the magnitude of Q multiplied by the sine of beta is going to equal this amount of projection on x-axis. So we're going to do Q sine beta in the x hat direction. Okay. Now we move on to the y-axis. Q is definitely pointing downward against the positive y direction. So that will receive a negative Q. And we want the adjacent side of beta onto the axis y. So we're going to use the cosine of beta, which would be this angle here, or this projection here. So Q cosine beta y hat direction. And that's it. That's the skill that we need moving forward through statics. Okay, that's all I got for you today. Preview of what we're doing next time. This problem, we're going to be identifying lambda. So we're going to compute the tension, tension alpha delta, knowing that tension alpha Charlie is 1,347 pounds. So stay tuned for that video. But for right now, I'm out of here. Bye-bye.